All right, thank you very much. My name is Yueshi. I work for Twitch. Today, I'm not going to talk about too much the AV1 technical details. Instead, I'm going to talk about, in order for a content platform like Twitch to deliver the end user benefit, to deliver commercial value, what are the building blocks that we are looking at? And how are we combining all of them together to build a working AV1 solution? So first of all, about myself. So I run the transcoder team at Twitch. I've been with Twitch for 4 years. Has been amazing growth. So I kind of define my job of I'm a bodyguard, one of the bodyguard of my senior director who's in charge of the whole video infrastructure team. So I build a core video technology for Twitch, like low latency HRS. So now across the board, our end-to-end latency is about, median is about 3.5 seconds, which is, we believe is, we are quite proud of that. I also build a high-density transcoding farm for Twitch. I'm going to talk about the volume of Twitch in a minute. I also made a little bit of a contribution to the AV1 standards, and I run the transcoder team. Prior to Twitch, I'm actually coming from the lead and TV background. I used to work for a chip company called Umbrella. If any of you remember the history of H.264, Umbrella built the first single ASIC for H.264 encoding. So I used to tune the video quality, watch a lot of, I guess, this codec engineer familiar with test footage of Sprinkle Ladies and the Park Run. But in the recent 5-6 years, I moved from traditional TV into internet. So that's about me. I'm going to talk a little bit about Twitch so that you can understand our business need. We claim we are the world's largest live streaming platform. Here, I'm going to show you a video.
Classics, but he might fall and continue to get ball control. Look at this play from Krenovia. Big aggressive move by South Korea.
What? No, that's not a thing.
You beautiful individual.
Oh, so does watching my stream. That's so cool.
You're teaching it the meaning of love.
He is going for it. This guy is unstoppable.
This is a very simple painting that you can do even if you've never painted before.
Let's get more butter.
Say hi.
Oh, that's it, baby! What a way to end! Wow, what a game!
All right, this is Twitch. I guess it's kind of funny that because of my work, I actually work with a lot of senior manager or sales director of different companies. And for many of those, they know Twitch because they have a teenage boy at home. I guess if you yourself have some family member of teenager boys, now you know what they do on Twitch. Okay, really, what I feel really excited about Twitch is I think we offer two big value to the broadcasting industry. First of all, we greatly reduce the barrier of entry to do live broadcast. Before, you kind of need to have some connection to Hollywood. You need to have access to these very expensive machine to a studio. Nowadays, as long as you have internet connection, as long as you have a PC, a simple setup like this, you can do broadcast. Anybody can do broadcast. Even I can do broadcast. Also, that we kind of invent this interactive live streaming model. So on the right, you can see this gamer is playing the game, and his audience are making comment about him playing the game. And the broadcast is expected to answer these comments in a timely manner. So in this way, both the broadcast and the audience are together making the content, and that making the content so interesting to watch. And so back again to our content, we are more a gaming platform. We do gaming and esports, but also original content. So for example, people broadcast the do cooking, or they repairing cars, or do weightlifting. A few weeks ago, I went to watch a ball game with my family. I found out that the taxi driver, he was actually, when he was driving, he was broadcasting on Twitch. He's just having a camera. So anyway, so we have a wide variety of content on Twitch. And we build a community out of that. So talking about the growth, it has been quite amazing. So the Twitch brand was kind of launched in 2011 as a spin-off from Justin TV. For people, if you know what, I still remember what Justin TV is. So this is the growth of our viewership. By the way, this is public data. If you go to twitchtracker.com, it's an amazing website. Somehow they track what Twitch does. So year over year, we have our viewership growth about 40%, which is actually, at this time of internet, which is different from early 2000, this growth is actually pretty impressive. So the most recent peak, we have about 3.5 million concurrent viewers. That's the E3 conference. If you're a gamer, you know what E3 is. On the other hand, what is even more interesting from an engineer point of view, the growth of broadcaster is even faster than the growth of viewers. So I mentioned the year-over-year growth of viewers about 40%. The year-over-year broadcast growth is about 60%. So you can see recently we have a peak more than 120,000 concurrent channels. So consider Twitch as an international TV station. At our peak, we have more than 120,000 channels. I don't believe there's any TV station is of this volume. And because of that, like similar to what Mark said for YouTube, so we also have a long tail of content. Majority of viewers are captured by this head content, like this esports program or the top tier gamers. But on the other hand, we have a huge long tail. And because of this kind of the state of the channels that really force us to design our solution in different ways. Okay, so I talk a little bit about the Twitch's business. Now I've kind of moved to talking about our business need, why AV1 is so important for us in the long run. So in order to explain that, let me first explain the operation point of Twitch. I think we are UGC platform, but our UGC is kind of very high quality UGC. Partially because of the gaming, and also partially because of our broadcast. No matter how many viewers they have, they are broadcasting, they are very tech savvy. They buy expensive machine to capture their game and encode it. Our top rendition is 1080p 60. Although I say 6 megabits per second, we recommend 6 megabits per second. In fact, our broadcasts can broadcast all the way up to 8.5. So 8.5 megabits is where we cap. Another special thing that we do is for the top rendition, we just transmux from RTMP to HLS. For all the rest of the rendition from 720p 60 to 160p 30 is we do the transcoding. And interestingly, because of our content, because of our audience, actually majority of our viewership is on 1080p 60. So you can imagine that we're actually shipping a lot of data. And again, we are using our own CDN, so we are a private CDN. So if you consider Twitch, compare Twitch to other public CDN, we, like volume-wise, we are probably one of the top 5 CDN in the world. So this is really the not an issue. This is a good problem to have, that we are shipping a lot of data, and which incur a lot of cost. So any technology that can do the compression better, can deliver same quality at a lower bit rate, is very valuable to us. And right now, what we do is we do VP9. It's the best solution at the moment. This is a photo that I gave a presentation with Xilinx CEO in last year's Xilinx like a developer forum. I was explaining why VP9 is useful to us. The reason is it can deliver high compression gain than H.264. However, it has its own shortcoming or has its own issue. And the reason is really HEVC and the VP9 are very fragmented. VP9 is not supported across the board. It is supported on Chrome and Firefox and on Android devices, but it's not supported on iOS or Safari. And that's really not, I mean, we do not see any hope that this is going to solve ever, which means this incur a few difficulties for us. So first of all, it incurred higher cost. For us, for this channel that we stream VP9, we stream both VP9 and H.264. And doing that means, of course, we need to pay more money for the transcoder because we need to have the dual stack. On the other hand, it incurs more cost on the replication, on the backbone. But of course, the benefit is we're saving the last mile, we're saving the egress traffic cost. But still, that we pay more on the transcoder, we pay more on the backbone traffic cost. So the other side of that, it actually bring a lot of a higher risk, the operation risk. So for example, right now, we're actually doing the staff release. We have 1,500 Android devices, kind of Android devices. We want to making sure that VP9 plays on them, and we do, it's just a lot of QA. And also for VP9 on the browser, different browser, and a browser on different GPU, CPU skills, to making sure that our player select correctly that this hardware platform can play VP9, then we give it VP9. Otherwise, we give H.264. It's very complex. It's very complex to build and very, very complex to QA. So because of this fragmenting of the codec support on the client platforms, we found it's actually pretty difficult to manage. So eventually, what we like to have is to see a single format that is cross-platform supported, and actually Twitch is kind of we don't care which one it is as long as there is one. But based on the data that we have collected so far, we believe AV1 has the best chance. So if in the future, AV1 is supported on all the browsers, on all the mobile platforms, that would be really nice. So that's one aspect. The second aspect is because we are doing this, so interaction is really important. So we care about one thing, which we call the hand wave latency. What it means is when the light, it's a latency that the light hit the camera until the time that the light emits from a viewer's screen. So right now, as I said, it's about 3-4 seconds. And the reason that HLS do have a few seconds of delay is because HLS that you kind of like divided a continuous stream into segments. At Twitch, we do 2-second segments, but according to HLS, their recommended duration is 6 seconds. This has an issue is for the ABR algorithm in the player, it really, in order to making sure that you don't run into buffer empty, it tries to buffer some video in the player buffer, so that if your bandwidth drops, it still have enough video to kind of consume. So if the segment size is 2 seconds, it has this switching opportunity every 2 seconds. If it's 6 seconds, it only can switch every 6 seconds. This really, so because of this limitation, really make the player very conservative. They are not putting too little video into the buffer, so otherwise it might run into buffer empty. So switch frame is a feature that we proposed and it was accepted in the AV1 standard, and it allows the player to switching not only at the keyframe or IDR frames, but also at some special P frames without sacrificing the video quality too much. So in this way, that an ABR player can switch more frequently, so that it doesn't need to buffer having too much video in the buffer. Again, just to recap, this cross-platform support and the low latency are the two main features that the Twitch care about AV1. So in order to achieve that, realize that, we believe that a healthy AV1 ecosystem is really important. That's what I mentioned, that all these building blocks that we need to make AV1 happen on Twitch. So this is, so Jan Oza interviewed me during NAB. So I told him like a 2024, 2025, he was a little surprised, but let me give you more details. As I mentioned, that Twitch has head content and tail content. For head content, which are the high viewership content, right now we are streaming both H.264 and VP9. We are expecting that in a few years, until 2022, 2023, the adoption of AV1, the penetration rate in a client device of AV1 is significant enough so that we can, instead of streaming VP9 H.264, we can streaming H.264 and AV1. Eventually, we are hoping in 2024, 2025, all 3-year-old device support AV1. So that eventually we hope that we can all move to AV1, both the head content and the tail content. But it's likely that there is some legacy device that we cannot get rid of. Then in this case, maybe we will stream AV1, which is a full 1080p, 4K, but for H.264 legacy devices, we only give you 480p. So nevertheless, this is kind of our dream. This is our projection. In order to see this happen, so this is another picture that I got from AOM, the website. So a few things need to happen. The chip company need to have the hardware support of AV1, and then device company need to adopt these chips and build mobile phone or set-top box that support AV1 hardware decoding. And then content platforms like Twitch can encode and stream AV1. But it's kind of a chicken and egg problem. Chip company ask us that when do you need AV1? When do you need it? We are asking them, when are you going to get it ready for us? But nevertheless, I think Twitch, we want to express a very clear message to the industry that we really want AV1 because it really helps us address these pain points that I just explained. So in order to see that happen, we kind of divide that into different kind of sectors, and we are actively tracking the progress of AV1 adoption. And we're actually talking to different different device company, SoC companies, and encoder companies, and to track the progress of that. So this is kind of the ideal timeline. If any of them change or doesn't match our projection, it might have some consequence on our timing of streaming AV1. Okay, so of course I talk about what we like to see happen, but back to the reality, there's lots of risks that, in fact, we as a content platform, we do not have too much control. So next, I'm really going to throw out some questions. I would like maybe working with this forum that hopefully I can get an answer from some of you. So talking about risk, actually, talking about AV1, people talking about the compression gain. Of course, that's the biggest benefit of AV1. But like more fundamental things are the legal risk and the decoder support. Without those two things resolved, no matter how good the compression gain of AV1 is, it's difficult for a content platform to adopt it. So I guess many of you are familiar with Cisvel's claim. They claim they have some patent in AV1. So I just quickly look at it. They are more so their royalty scheme is more for the client device. On the other hand, we kind of expect there might be new more patent trolls coming up. Really, me as an engineer, I don't know too much, but I would like to see whether there's any data point so that our lawyers or our partners' lawyer can quantify the risk. I really don't have answer for that, apart from some a public announcement of AOM. I feel there are too few data points for lawyers to quantify the risk. And as we talk to some SoC companies, it is actually a concern that they don't really believe that it's completely royalty-free. So that's the one big legal risk. Second one is the decoder support. I think it's progressing pretty well. So first of all, let me explain. For Twitch, our majority of our traffic is on browsers. The second biggest category is the mobile platform, iOS and Android. But we also support the streaming boxes, set-top boxes, and the game console. As browser being our account for majority of our traffic, seems to be going pretty well. Edge, Firefox, Chrome, apart from Safari, everybody supports AV1. And also in Android Q just recently announced that they will support AV1 decoding. So that's fantastic. However, one thing that we feel is at least in the next 1 or 2 years, we might have to rely on software decoding. When it takes time for the SoC company to make the chip and the phone company or hardware companies to build the device, and for the market to do the upgrade, for consumer to upgrade their devices. So from now in the next 2 years, we might have to rely on the software decoder. I understand that David is making great progress on performance. On the other hand, I also saw some demo that the AV1 decoding is really draining the battery just so quickly that it's not quite, I don't know, but I haven't received a data point that it's a solution right now. So what I really would like, I think there's some David talk later today, but the data point that as a content platform would like to see is what is the battery life, and also if it's decoded on a modern CPU, how many core it takes. So that's a software decoder. For the hardware, for the encoding part, our bar is we expect eventually AV1 for the head content can deliver same quality, similar, comparable to H.264 medium, but with 50% of bitrate saving. For the tail content, the bar is a lot lower. It's H.264 very fast with 50% bitrate saving. For the tail content, this is actually not only for our broadcast model. We also talk to multiple Amazon companies. Some of them do the RTC, like a teleconferencing, whatever, this real-time communication business. So this is also their bar. So one puzzle that I have is, so when I look at the AV1 standard, there's a lot of tools. For example, it enables a lot of modes. It can enable more reference pictures and have this wedge prediction. And how can I know that all these are implementable to achieve real-time encoding? Because that's really indeed a much more difficult problem than offline encoding. What hardware platform do we need? Can we realize by software, or we have to use some ASIC? We don't really see too much data point for us to do the projection. So nevertheless, let me recap here. So today I talk about, first I talk a little bit about Twitch, which is a live streaming, it's a content platform. Our long tail content is really long tail. We have, at our peak, we have 120,000 concurrent channels. Right now, for the head content, we stream both VP9 and H.264. But we believe that might not be it might not be sustainable because streaming in multiple formats incurs more cost and operation risk. So ideally, we would like to see the whole industry moving towards one single format. So in order to create a healthy AV1 ecosystem, that we require support from the SoC companies and device and client device companies and browser companies, as well as backend encoder companies. So after these become mature, then the content platform can adopt AV1. When we look at this trend, so what we are concerned are the legal risk and also the market penetration rate, the adoption rate of decoder support, and eventually the encoder performance for live encoding. Okay, so that's my talk. Any questions?
Thank you so much. We have some great questions from the audience as well too. And just a reminder, you can jump on the bigapple.video website and ask questions. Where should I start here? Oh, this was a pretty easy one. What is the threshold to classify head and tail channels?
Well, it's actually not a simple question. So our data scientists did a lot of research. I think we actually have different tiers. We have tier 0, which is the top tier, which are the ninja. If you know who ninja is, he can have 100,000 concurrent viewers. All the way down to my channel has less than 3 viewers. We don't have really a cut-off point. You can kind of say the top are maybe a few thousand concurrent channels, then the rest are the tail.
Great. Okay, so are you allowed to switch resolution at switch frames in both directions, or only from high res to low res?
That's another excellent question. It's for both directions. So in VP9, there is a feature called resolution reference frame. So it allows for one single stream to change the resolution in the middle. So the switch frame kind of extend this idea that they're independent encoders. They don't know that the users are switching in between. But at the switch frame, the user can freely switching from any resolution to other resolution, which is actually more flexible than the SISP frame in H.264, if any of you remember what that is.
Okay, I'm going to keep it on AV1, and then there's a few questions about VP9. So is Twitch investing in development of AV1 encoders and decoders to mitigate the risks that you've mentioned?
Okay, so I'm not sure. Are we developing AV1 decoder encoder? We are not developing AV1. We are not a codec company. We rely on the industry to provide a solution for AV1. That's the reason I mentioned that a healthy ecosystem is really, really important. So actually, when we talk to the chip companies, to support too many codec format is really pain, because they have to invest all the money or the R&D, and their die size become bigger. So if the whole industry can merge towards one single format, it's a lot easier for everybody.
Yeah, and we'll have Ronald here speaking about some David stuff as well as some encoder stuff later today as well, which is part of that healthy ecosystem. A few questions on VP9. When do you start planning on transcoding VP9? No channel has VP9 at the moment.
Yeah, so right now we are doing the staff release. So depending on the feedback that we already get some feedback. There are some issues that technical issues we are fixing. As soon as that concludes, we will soon do the beta release. We actually have quite a few broadcasters that they volunteer to work to use VP9 for us to use VP9 on their channels. So
I'll push that.
Okay.
And yeah, you've pretty much answered that. And do you plan to support SRT on the stream side so people can send VP9 directly?
Using SRT, okay, so that's another hot topic here. So SRT for us is, the benefit of that is a lot of professional encoders support SRT. So for example, the esports or a top tier broadcast in the field. We don't have a concrete plan right now, but we are actively investigating into it. On the other hand, a lot of our broadcasters, they are tail broadcasters. They probably do not have money to invest a $5,000 encoder, professional encoders. To address that market need, we might consider using WebRTC or other kind of like more open source standard.
Great, thank you so much. And there was one question about the presentation and will it be available? And it will be available online. And we have one question from the audience. Let me just grab that one over here.
So the switchable frames, are they completely reliable, or because I've heard that they aren't bit exact. I mean, they aren't.
Yeah.
They aren't deterministic entirely.
That's right. Yeah. So they are not supposed to be bit exact. So if you think about prediction, the prediction basically two parts. One is the prediction of the pixel. The other is the prediction of the motion information. So the switch frame basically turn off the prediction of the motion information. But for the pixel, because they're just the same content but of different resolution, and we can use that. So it's not bit exact, cannot be, but it's still pretty good. Particularly you're switching from high resolution to low resolution. We don't. I mean, from our test, we haven't seen this being a problem. Yeah.
Great. Thank you so much. Thank you for being here. Really appreciate it. Fantastic. So just so everybody knows, all of these speeches are going to be available online on the Big Apple video website. Each of the speakers have a defined page, and all of those talks will be available on there. We will be going and grabbing some lunch, and then we will be live again in a couple of minutes as well too. So we can cut that.